unless you get right 0.
Yeah.
Alright, so what we're going to look at today, it's called congruent triangles. Congruent is a fancy way of saying two things are identical in terms of features. So if we're looking at congruent triangles, that means that we're looking at two triangles that share all the same features. So their side lengths are exactly the same, and their angles are the same, and they're all in the same configuration. So the side lengths that are the same correspond to the angles that are the same as well. The only things that can be different in congruent triangles is that their position might be different, their reflection against one another might be different, so they could be reflected to one another or they could not be reflected. And similarly, their rotation might be different, so their position in space might change. The way in which we can check if triangles are congruent or not is we have 4 different rules. First one is side, side, side. So if all the sides of a triangle are in agreement, then they're congruent. So if you can show that all 3 sides of each triangle are the same, congruent. And the rule is side, side, side. This one over here, right angle, hypotenuse side. If the triangle is right angled, they share the same size hypotenuse, and one of the other sides is in agreement with the other one, then that's a congruent triangle. It has to be. Next one, side angle side. This one is where you can make mistakes. The sides have to be, the angle that's common between the two, or common between the triangles, has to be sandwiched between the 2 sides. So if the angle's over here and the sides inside are there, it doesn't work. So the angle has to be sandwiched in between. It's like the cosine rule. Can you guys touch your elbows together? Yeah, so if the sides are like that and the angle's in between, then it's not that, it's side angle side. I know what I was thinking there. So we call it side angle side. The other one is when the side is sandwiched between the 2 sides, and that one's called angle side angle, or ASA if you want to do it for short. Now where we can go with this is we can prove the triangles are congruent, which in itself isn't that useful. However, when we're solving geometric problems, knowing that triangles are congruent allows us to make assumptions about the rest of a question, or assumptions about a system, which happens quite a lot in stage 2 spec mathematics. So where we draw our attention is over here. What we want to do is we want to show that triangle FAB, so this guy in here, is congruent to triangle BCD, so that guy shown there. The way we're going to do this is we're going to show that those 2 triangles share one of the rules over here, or share the properties of the rules over there. Given that this is a regular hexagon. Now, just looking at these, what do we need to try and figure out if we're dealing with some sort of, I guess, congruent triangles? What sort of properties are we trying to show are the same? Side lengths, angles. If this is a regular hexagon, what do we know about its side lengths? Yeah, we know that they're all the same. So we know that this is the same as that, which is the same as that, which is the same as that. And it'll be the same as that and that as well, but I'm not going to worry about it because it doesn't give us anything. So I might say side FA is the same as side AB, which is the same as side BC, which is the same as side CD. And my reasoning for this is going to be regular hexagon. Cool. The reasoning doesn't always have to be what we looked at last lesson. Sometimes it can just be a statement of, well, this is a regular hexagon, or this is a regular pentagon. Next, we know the sides are the same. We can go down 2 routes. We can try and show that this side length here and this side length here is the same. Or we could try and show that this angle and this angle is the same. So therefore we'd be going for the side angle side, or we're going for the side side side. What seems the most rational way to go down, Matilda? Rational being what's going to require the least amount of effort? The sides we could. Is there any rule that might allude to the length of that side length though? I mean, it's obvious it is, but can we give any form of reasoning for it? Oh, performance. Looking sharp. This is where I always used to get stuck on the geometry because I could see it, but I didn't know how to show it or how to write it in a single way.
What did you sub it with there?
Think about the properties of regular hexagons. The sides are all in agreement with one another. And if the sides are in agreement, what else would be in agreement? Yeah, the angles. So these angles over here, they're all going to be, including this one, and including these guys, they're all going to be the same thing. The angle itself, let's say this angle here, so angle FAB, is going to be the same as angle BCD. And where else are we? That's all going to be equal to 180. There are 1, 2, 3, 4, 5, 6 sides. Take 2. And there are 6 sides. So they're all going to be equal to that based on one of the angle rules we learnt last lesson. Well, I didn't tell you, I just told you it existed on the OneNote. So we know that all the internal angles would be this angle over here. Welcome, Nick. We could calculate it, but we don't need to. But if we know that this angle and this angle are the same here, do we have enough information to conclude we're congruent? Yep, we sure do. So this is still regular hexagon. So therefore, triangle FAB and triangle BCD, these guys are not just equal, they're congruent. They're exactly the same. Does this make sense? So in terms of what's happened here, when we're trying to prove congruency in triangles, basically we need to make 3 statements. I only made 2 because this is 2 statements. Single statement. The other route you could have gone down as well is because this side and this side are equal and this side and this side are equal, you know that those triangles are both going to be isosceles triangles. And if those triangles are isosceles triangles, then this angle here and this angle there these smaller angles are exactly the same. Justification, isosceles triangle, therefore triangles must be congruent. All cool? So we could have ended it after there. Any questions? Alright, so what you're going to first start off with is you're just looking at triangles and you're deciding if they're congruent or not based on the arrangement of their features. After that, there's about 5 questions where you're getting geometric arrangements like here. They're going to seem there's a highly likely chance that they're going to seem really tricky and alien to you because you may not have done this before, in which case just ask yourself, what do I know? What is obvious and what do I know? Write it down, state your reasoning. It can be whatever you decide it needs to be. Just try and keep it to a few few words. If it's a few sentence, if it's like a sentence, it's probably too complicated. Keep it to a few words, and then see if you've got enough information to make your conclusion. Cool.